This is what a math teacher does on a walk with her girls. Ready, girls?
Mm-hmm.
X equals negative b.
X equals negative b.
Plus or minus the square root
Plus or minus the square root
of b squared minus 4ac.
of b squared minus 4ac.
All over 2a.
All over 2a.
Quadratic Formula Part 2. Today we're going to really learn how to use it and practice it, as well as practice memorizing it. Right now, you might be like,
b plus or minus the square root something something I don't know. All over 2a.
but with enough practice, hopefully by the end of this lesson, you'll have it stuck in your head for the rest of the day. This should be a good start.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
You better be singing along now. Try it again.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
All right, one more time. Ready?
Is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Got it down? All right. Let's get started on some problems.
Equals negative b plus or minus the square root b squared minus 4ac all over 2a.
I think it helps to start writing out the quadratic formula with parentheses for all of the a, b's, and c's. That way you can very easily identify a equals 6, b equals 5, and c equals negative 4. The negative goes with the 4. And you can plug those numbers into the spots where they go. B is 5. B squared would be 5 squared. A would be 6. C is negative 4. And that final bottom A would be 6. If you remember from yesterday, what is the first part of the quadratic formula that we start to solve? The discriminant, the part under the square root. When we solve that part first, we get 5 squared is 25. And if you have any trouble with negatives, scooch this negative to be next to the negative 4. Then you can simply either plug it into your calculator or think about it. Negative 4 times 6 would be negative 24. And negative 24 times negative 4 would be positive 96. Keep that under the square root and bring everything else down. Simplifying, we get 121 under our square root. We can also simplify the denominator to be 12. This is the piece where we break up our equation into two pieces. The first piece is going to be using the positive part of our formula. So x will equal negative 5 plus the square root of 121 over 12. And the second piece will be using the negative portion of the formula. X equals negative 5 minus the square root of 121 over 12. Now, lucky for us, 121 is a perfect square. The square root of 121 is 11, which makes our answer a lot nicer. Negative 5 plus 11 over 12, simplified down to be 6 over 12, or 1/2. So our first solution, or 0, or root, would be at 1/2, positive 1/2, 0. 1/2 would also work if I plug it into this equation up here at the top and plug it into my calculator. That would equal 0. It would check out. All right, looking at our second or negative version of the answer, we have negative 5 minus the square root of 121, which is 11 over 12. that would simplify down to be negative 16 over 12, which would reduce by 4, dividing both by 4, as negative 4 over 3. So our second 0 would be at 1 1/3, or negative 4/3, 0. And our parabola, we know, will be opening upward because it has a positive a of 6, and it will look something like this. We could find the vertex exactly by using negative b over 2a. We'll leave it at that for now. Also note that if I plug negative 4/3 in for x, right here, and I solve or simplify in my calculator, I will also get 0. These are the two values for x that make our original equation true. They're also the x-intercepts, or the places where the parabola crosses the x-axis. Looking at example number 2, notice that this is not in standard form right now. All of my variables and terms need to be on one side of the equation before I can identify a, b, and c. So the first thing I need to do is subtract x onto both sides to get x squared minus x equals 20. And lastly, I need to subtract 20 from both sides to get x squared minus x minus 20 equals 0. Noting that now our a, b, and c will be correct. A would equal positive 1, b would equal negative 1, and c would equal negative 20. Time to plug into our quadratic formula. I think we need one more fun one. You guys better be glad we're doing distance learning, otherwise I'd be making you do what this class was doing.
Equals a negative b plus or minus the square root of b squared minus 4ac all over 2a.
You guys have it memorized yet? Let's write it out with parentheses for each of the a, b, and c for easy plugging in. All right, our first thing is negative b. b is negative 1. Remember those parentheses? Make sure you include them. Next we've got b squared, so we're going to put in negative 1 squared. Then we've got a is equal to 1, and c is negative 20. See if I can fit it in there. All over 2a, 2 times 1. Remember, the first part is to evaluate the discriminant, the part underneath the square root. Negative 1 squared is a positive 1. Negative 4, oh, actually, let's do what I told you before. Let's scooch this negative to make it plus a negative 4. That way you don't accidentally mess up your negatives. So then we've got plus, and we've got negative 4 times 1 times negative 20 would be positive 80, all under the square root. Simplifying down, we can have 81 under our square root. Negative 1 is just a positive 1, and 2 times 1 is just 2. And now we split into two pieces. Our first piece has the positive portion of the root, x equals 1 plus the square root of 81 over 2, and the second one is our negative portion of the solution, x equals 1 minus the square root of 81 over 2. Here again, we are kind of lucky. This is a nice perfect square. The square root of 81 is 9. So we have x equals 1 plus 9 over 2, and x equals 1 minus 9 over 2. Our first solution would be 10 over 2, or 5. And our second solution would be negative 8 over 2, or negative 4. So our two roots then would be at positive 5 and negative 4. Because our a value is a positive, our parabola would be opening upward and looking something like this. And again, if I was to plug in the value 5 in place of x in this original equation, 5 squared is 25. Plug in 5 here. 5 plus 20 is 25. That would check out. If I plug in negative 4 squared is 16. 16 equals negative 4 plus 20, or 16. That checks out. So these two solutions not only are the zeros, or the x-intercepts, but they also make our original equation true when plugged in for x. All right, there you go. You have all you need to know. Just be really, really careful about your order of operations. Remember, when you are doing your quadratic formula, please do what's under the square root first, very carefully. Remember to move your negative to be part of the -4. So I see a lot of mistakes under here with people messing that up. And then make sure that when you split your answer into two pieces, that you simplify the numerator first. Put it in parentheses if you need to. Plug it into your calculator, hit enter before you divide by that final number. Good luck. I hope you have this quadratic formula stuck in your head and sing along as you work through your problems today. Have a good day.